Two particles A and B of equal masses are suspended from two massless springs of spring constant K1 and K2 respectively. Right. Basically, let us see what is happening. Basically, there are two masses. Right. They are attached from the spring A and B. They are having the same masses, but K1 and K2 are basically different. Right. This is B. This is having the same mass, and this is K2. Right. If the maximum velocities during oscillation are equal, the ratio of amplitude of A and B are, right. Now it is saying that the maximum velocity is equal. Now let us see for a general spring mass system what happens. If this mass is at its mean position, if this is mean position, now what happens at mean position? At mean position, this block has Vmax, right? This block has Vmax, and at extreme position, let us suppose this is the extreme position. This is extreme position, right? What happens at extreme position? The distance between the mean position and the extreme position is called the amplitude A, right? Or we can write it as capital A basically, right? This is basically the amplitude, right? And at that extreme positions, what happens? Velocity becomes zero. Because if it is having some velocity, this particle would be still moving down, right? Since it is changing its direction, the point where it changes its direction, its velocity becomes zero, right? Now, we know that at the mean position, its extension will be zero, delta x will be zero, right? Extension will be zero. That means at that point, what will be the total energy? The total energy will be equal to what? Half m Vmax square, right? Now, since energy is conserved at the extreme position, what will be the energy? Now, at this point, total energy is half m V max square because delta x 0. That means half k delta x square is 0, right? And at the extreme position, what energy does it has? Half m V square, but V is 0. So that means we can chuck it out. This will be 0 plus half k1 x square, or I can write this A as the amplitude, right? So that means from this equation I can get half k1 A square will be equal to half m Vmax square, right? So that will give me A will be equal to Vmax into under root of m by k1. This is amplitude 1 for particle 1. This is A1 basically, right? So I get the value. This is so similarly for block B, A2 will be equal to what? Vmax into under root of m by k2. Now block 1 and block 2 have the same maximum velocity and they have the same masses, right? So that means if I calculate the ratio of the amplitudes, which will be A1 by A2, that will give me under root of k2 by k1, right? Why will it give me k2 by k1? Because Vmax and mass m will cancel out. So I'll get this answer. So that means option C is correct.